All right, so we're going to start off with solving equations for the review. Remember, our goal is to get letters to one side or variables to one side and numbers to the other. And so as I look, I'm going to move the negative 7k across the equal sign. So when I do that, I do the opposite. So I'm going to add 7k to both sides. So I get 1 plus 5k is equal to negative 14. And then we're going to get our k alone. So we're going to get rid of the positive 1. So we get rid of positive 1 by subtracting 1. We're doing the opposite. So we have 5k is equal to negative 15. And then we're going to divide both sides by 5. And so we get k is equal to negative 3. If we look at number 2, you'll notice that we have like terms on each side. So you have 3k and 7k. And because they're on the same side of the equal sign, we're just going to add them together. So 3 plus 7 is 10. So we have 10k minus 4. When I look at the other side of the equal sign, you should be noticing that you have a 6k and a 6k. So those, again, are like terms. So 6 plus 6 is 12k plus 12. And now we're going to bring letters to one side. So we'll subtract 12k from both sides because we want to bring letters one way. And so 10 subtract 12 is negative 2k. The 4 is going to come down. And then we have 12 on the other side. And then we're going to get rid of the minus 4 by doing the opposite, which is adding 4. So we get negative 2k is equal to 16. And then we are going to get rid of negative 2 by dividing. So we're going to divide both sides by negative 2. And so k gives us negative 8. As we look at example 3, we're going to do distributive property first. So negative 8 times 1, or times n, is negative 8n. Negative 8 times negative 1 is positive 8. The negative 6n and the negative 90, we're just going to keep where it is because we didn't distribute. It was inside the parentheses. We have like terms with the negative 8n and the negative 6n. So negative 8 subtract 6 is negative 14n. And again, they're on the same side of the equal sign, so we do not do the opposite. We just combine like terms. We're going to get rid of positive 8 by subtracting 8. So we get negative 14n is equal to negative 98. And then we're going to undo multiply by divide. So we're going to get n is equal to, what is that, 7. If we look at example 4, same thing. We're going to do distributive property with the negative 1. So you've got negative 2. Negative 1 times 4 is negative 4n. On the other side, we're going to distribute the 2. So 2 times negative 8n is negative 16n. 2 times 4 is 8 plus 2n. And then again, we're going to combine like terms. On the left, we don't have any like terms, so we're just going to leave it. On the right, we have n's. So negative 16 plus 2 is negative 14n plus 8. And now we're going to bring letters to one side, numbers to the other. So we're going to add 14n to both sides. So we get negative 2 plus 10n is equal to 8. We're going to add 2 to both sides. So we get 10n is equal to 10. And then we're going to get rid of the 10 next to the n by dividing. So we're going to divide both sides by 10. So n is equal to 1. And that's just a quick review of solving equations. Problems 5 through 10 are 8.1, which is solving proportions with triangles. And so remember that as we write our first proportion or our first ratio, it doesn't matter how we write that. So if I was going to do number 5, I might say 2 over 6. So notice I went from the top to the bottom on that right-hand side. So I need to go across from the 2, which is x minus 7. So it needs to stay on top. And then over the 9, because that's across from 6. And then once we're there, then we're going to just do cross product. So we're going to go 6 times x minus 7 is equal to 2 times 9. And then we're just doing our normal solving equation. So 6 times x is 6x. 6 times 7 is 42. 2 times 9 is 18. And then we are going to add 42 to both sides. We get 6x is equal to 60. And then solve from there. So we're going to divide both sides by 6. So x is equal to 10. Number 6 is similar. Again, you've got your parallel lines. So as long as you have parallel lines, or like a parallel line that's, if you have a line that's parallel to one of the sides of your triangle, then you've got that ratio proportion set up. So again, as we look at it, if I decide to go 15 to x plus 4, which is fine, then I need to go the one across from the 15, which is 10, and I'm going to go over to 6. So I'm going to have 10 over 6. And then we'll just do cross product. So again, we're going to go 10 times x plus 4 is equal to 15 times 6. And so 10 times x is 10x, 10 times 4 is 40, 15 times 6 is 90. And then we're going to get rid of the 40 by subtracting, because we're always going to do the opposite operation. So 90 minus 40 is 50. And then to get rid of the 10 next to the x, we're going to divide. And so we get x is equal to 5. When I look at number 7, it's a little bit different. As you notice, the whole entire side is 24. So if I go 24 subtract 16, then we know that this little segment is 8. So again, as we look at it, if we're going to go from 8 to 16, which is fine, then we need to make sure we're going across from the 8, which is 2x minus 2, to 20. And then again, we're going to do that cross product. So we have 16 times 2x minus 2 is equal to 16 times 20. So 16 times 2x is going to give us 32x. 16 times 2 is 32. And then 16 times 20 is going to give us 320. So to get rid of minusing 32, we're going to add 32. We're going to get 32x is equal to 352. And then to undo or to get rid of the 32 next to the x, we're going to divide by 32. And so from there, if we divide, we're going to get x is equal to 11. So 32 or 35 divided by 32 is 1 with 3 left over. So 32 into 32 is 11. And then as we look at number 8, kind of the same idea. If we know the whole entire length is 24, then 24 minus 20 is going to give us this little section is 4. So if I go 25 over x plus 1, then I need to go the number across from 25, which is 20, and we're going to go 20 is to 4. And then cross product. So 20 times x plus 1 is equal to 4 times 25. Distributive property, so 20 times x is 20x. 20 times 1 is 20. 4 times 25 is 100. We'll subtract 20 from both sides. So we get 20x is equal to 80. And then from there, same thing. We're just going to divide both sides by 20. And so we get x is equal to 4. As we look at 9 and 10, we're talking about similar triangles, which is kind of what we've done before. but we looked more at triangle proportionality. When I look at similar triangles and I'm setting up that idea of the sides being proportional, we want to make sure that we have the sides that correspond marked. So you'll notice that S comes first and D is first in the second triangle. So that means we know that angle S is congruent to angle D. And remember when we talked about this in Unit 7, we talked about how if they were similar, the angles were always congruent and the sides were proportional. So when I look at R is in the same position as C, so we know that R is going to be equal to C. And the reason why that helps me is it helps me figure out which sides are going to be proportional. So as I look, that's really all I need to do, is because I know that B and Q have to be equal as well. So as I look at my first triangle, if I decide to make it go 11 over 8, if I do 11, I'm going the 1 marking to the 2 markings. So when I go to the other triangle, I need to go to the side that's between the 1 and the 2 markings, which is 13x plus 1. So those are the sides that correspond or in the same position. So if I look at 8, 8 is between nothing and 2, so between nothing and 2 is 48. So I know that this has to be 48. And then I'm just going to do the same thing. Now, remember we talked about this in class as well, is like I don't have to go 11 over 8. I could have gone 11 over 13x plus 1 and then 8 over 48. Like it doesn't matter as long as you're consistent. So as we do cross product, again, we're going to go 8 times 13x and then 8 times 1. So we're going to go 8 times 13x plus 1 is equal to 11 times 48. So we're going to do that cross product and make sure that we're multiplying the correct values. So we're going to go 8 times 13. So we're going to have 104x plus 8 is equal to, and then 11 times 48 is 528. And then from there, we're just going to solve like we've been doing. So to get rid of positive 8, we're going to subtract 8. So we get 104x is equal to 520. And then we're going to divide by 104 on both sides. So that should give us 5. And then again, as we're looking at the next triangle, notice that N is going to be equal to N because those are vertical. And then M has to be equal to G. So M is going to equal G. And now we have enough things marked that we can just go from there. So as we look, notice if I'm going between 2 and 1, that's the 22 here. So to go between 2 and 1, that's the 11 on the other triangle. So as you set up your proportion, now we know what's going to be over what. So if I look at the first triangle, we're going to go 22 over 16. If I look at the second triangle, then we're going to start with the 11. So we'll have 11 over x plus 1. And again, we're just going to do cross product. So we have 22 times x plus 1 is equal to 11 times 16. So 22 times x is 22x. 22 times 1 is 22. 11 times 16 is going to give us 176. And then from here, we've just got our normal problem. So we're going to subtract 22 from both sides. So 22x is equal to 154. And then 154 divided by 22, because we want to undo that by the opposite operation. So we'll divide both sides by 22, and so we get x is equal to 7. All right, our last little bit is solving parallelograms, and a couple things we want to remember. If we have opposite angles, so notice these are angles, if we have opposite angles, then we can set them equal to each other. So we're going to go 9x plus 6 equals 114. We're going to subtract 6. And so when we subtract 6, we're going to get 108. And then we'll divide both sides by 9. And then x equals 12. So that one's not too bad because it's angles that are across from each other. So across from each other always end up being equal to each other in a parallelogram. When we have angles that are next to each other, like example 12, then we know that these two angles are supplementary, which means I can add them together and I would set them equal to 180. And that's always true when we have a parallelogram. So if I combine like terms, 60 minus 4 is 56. So we have 56 plus 31x is equal to 180. And now we're back to that normal two-step equation. We're going to subtract 56 from both sides. We get 31x is equal to, what is that, 124. And then we're going to divide by 31. So then x is going to give us 4. All right, so that's again when we're talking about angles of a parallelogram. Diagonal from each other, we set them equal to each other, next to each other, or consecutive. Okay, so next to each other, we always add them together and set them equal to 180. Example 13 and 14 are talking about sides. So we know that if you have sides of a parallelogram, they should be equal to each other. So we'll go 2x plus 1 is equal to 13. And then we're back to that normal one-step equation, two-step equation. 13 minus 1 is 12. We're going to divide both sides by 2 to get our x equals 6. If we look at 14, the same idea. They're across from each other, so we can set them equal to each other. So we have 5x plus 2 equals 17. We're going to subtract 2 from both sides. And then our last step again is to divide by 5. And then our last two examples are examples where we have diagonals. With diagonals, if it's just the diagonals of a parallelogram, then we know that they bisect each other. So in this case, they're telling us this whole entire length right here is 28. So if it's being bisected, then I know that there's 14 on this side and 14 on this side because it was 28 total. The other thing that we're told is that from G to X, which is this section from here to here, we also know that section is X plus 7. So we're going to set these two equal to each other because they're both in the same position. So we have x plus 7 is equal to 14, not 28 because we've divided it in half. And then we're going to subtract 7 from both sides. So we get x is equal to 7. When I look at 16, it's a little bit different. It tells me that VJ, which is this little part, is equal to 8. And then it tells me JT, which is this part, is equal to x plus 3. But again, we know that the diagonals bisect each other, so we know that this segment should be equal to this segment. And so then we just set them equal to each other. So x plus 3 is equal to 8. We're going to solve that by subtracting 3, and we get x is equal to 5. Make sure that you ask if you have questions on any of this and you need more explanation. So hopefully that helps you if you are struggling.